Hey guys, hello everyone. Welcome to Rasayan Academy. So there's a very important topic about which I want to discuss with all of you. That is, students have been asking me, ma'am, please tell us important topics and what are the important topics to crack the CSI net examination. So guys, it's not 10 or 12 topics that completes the CSI net syllabus. There are at least 120 to 130 topics that which I have divided the whole syllabus into, and I think it will be really good if you are studying topic wise for the CSI net examination and not for the not chapter wise. Why? Because the chapters are big and you might not find the CSI net syllabus very much defined in two chapters, right? The syllabus is defined in two topics, and those topics you're going to understand thoroughly and just complete those topics. You will be able to answer the questions really nicely, right? So I have divided the whole syllabus into 130 or 125 such topics, and I'm going to discuss all those topics. I'm going to give you a list of all of those topics, right? So that you can have a clarity on how are you going to prepare for the CSI net examination, right? All you have to do is before watching this video, you have to you're right, you just have to have the patience to stick till the end, right? And the second thing is, after you watch the video and you realize that okay, these are so many topics, some of them I know, some of them I don't know, you have to comment which topic you want me to do next, that is which topic you want me to make a video on, right? So definitely I can help you with some of those topics, not all of them, because that's going to be like really time taking, and maybe your September exam will be over by then. But yeah, I can help you in few topics, and you can just mention which topic you want on priority. Also, what do you want me to elaborate on for the CSI and net preparation? Like, what do you want to know, guys? You want to know about the book source? You want to know how to prepare the strategy? We have already discussed the preparation of part C strategy, right? Yeah, what else do you want me to tell you? Right? You can just write in the comment section, and I'm just going to elaborate or about it in the next video. All right. So yes, let me just give you a list of all the important topics for your CSI net preparation, and this video is going to help you until and unless your CSI net syllabus is changed. All right. So yeah, let's start the discussion. First of all, guys, let's keep it simple. As you know that my channel is mostly focused on organic chemistry. So I'm just starting from some of the topics of organic chemistry only, right? So yeah, first and the most important is we always start understanding any chapter from reaction mechanism, right? So in the organic, we start from reaction mechanism or the basic concepts, right? So first thing I want to tell you is, please be very careful and very thorough with neighboring group participation. This is a one separate topic. You have plenty of examples, very beautiful examples in this category, neighboring group participation, NGP. Second topic is fragmentation. All right. So, guys, you can see I have not divided chapter wise. I have divided the topics. Okay, so that you can do one topic, you can just tick it off and you are confident ki chalo, this is done. All right. So NGP is important. Fragmentation is very, very important for both the CSI and NET, GATE examination, Barc examination, everywhere it's asked. Then third is elide formation and reactions. Okay. So elide formation and reaction. So you have seen this, guys, in the Korechkovsky reaction, name reactions. You have already seen how can we form the elide in the Wittig reaction. Also, you have seen this. Okay. Right. Next is about the elimination. Syn and anti-elimination. So what are syn elimination reaction? What are anti-elimination? Please know about this. Okay. Next is radical cyclization. Right. It is a very important concept, and you must know this for whichever exam you are studying for. Radical cyclization. All right. Sixth is dynamic stereochemistry. Now, what do I mean by dynamic stereochemistry? Stereochemistry, which is used in each and every reaction, like all the pericyclic reactions, like simple reaction, addition, elimination reaction, everywhere. So that is the stereochemistry of different molecules, how they are reacting, that is dynamic, that is moving, that is stereochemistry involved in reactions. Dynamic stereochemistry. Where can you follow this? You can follow dynamic stereochemistry from your standard organic books like Clayden. Obviously, there is not a chapter like this, but the stereochemistry of reactions, that is dynamic stereochemistry. Alright. Then we talk about conformational analysis. Conformational analysis, that is, first of all, when you want to discuss the conformational analysis, you need to check it for the aliphatic molecules. Alright, for the aliphatic compounds, that is for butane, ethane, substituted ethane, and so on, right? For aliphatic compounds, and the same conformational analysis for cyclohexane. Alright, for cyclohexane. Very, very important, guys. What is asked? Conformational analysis of cyclohexane, different types of reaction. Once again, conformational analysis and dynamic stereochemistry, they go hand in hand. So you have to do both of these, right? Then another important topic is chemoselectivity. What is chemoselectivity? There are plenty of questions in the exam which have been asked on this topic. Chemoselectivity is basically defining that which group, there are a lot of functional group in the molecule, which group is going to react with a particular reagent. That is chemoselectivity. Alright, you have plenty of examples of chemoselectivity. Then you have protection and deprotection. Very important topic. Protection and deprotection. Point number 11 is regioselectivity. Yes, guys, I've made a very long list, and I just hope that every time I'm writing a new topic, you're able to understand that really this is asked. Okay, so regioselectivity, protection and deprotection. Then there are concerted reactions. What is the difference between normal ionic mechanism and concerted mechanism? Concerted reactions. Who falls under concerted reactions? All the pericyclic, basically. All the pericyclic will fall under the cycloaddition, electrocyclization, the sigmatropic reaction, ene reaction. All of them will fall under concerted reaction. So this is another topic. All right. Now let's move onwards. Point number 13. Yes, you also have to have a little idea about the disconnection approach. What is the disconnection approach? How you are disconnecting the molecule, or let's say what is retrosynthesis? Even if not very hugely it is asked, sometimes it is asked what are the synthons, right? What is the synthetic equivalent of this anion or this cation, right? So you must know, must have an idea about retrosynthesis. Very little bit, but yes. Alright, then you have rearrangement reactions. There are plenty of rearrangement reactions which are asked, right? And the most important and the most usual one is the rearrangement of a carbocation, right? Very frequently asked. Rearrangement reaction, rearrangement of carbocation, of isocyanates, of, yeah, plenty of rearrangement reactions which are asked. Okay. Next is radical reactions. Now, what comes under radical reaction, guys? Everything which involves radicals, single electron transfer, metal, dissolving metal reduction, everything. Alright, so radical reactions are really, really important. You have to be very careful. Just prepare them nicely. Alright, then next is Carbene reaction. Reaction, generation and reactions of carbene. Carbene, study this as a topic. Definitely this topic can become a chapter also. And yes, there are plenty of examples to study from Caruthers and Clayden, but absolutely it's very, very important. Okay, then now guys, studying about the carbene, you can also, talking about reactive intermediates, you have also got to study the reaction of benzene, the selectivity in the formation of benzene and the reactions of benzene. right? When you are studying selectively, guys, you can just complete this topic and you can get done with it. You will be motivated that, okay, I have done so many topics. Out of 150 or 120, I have done so many, right? So that's going to give you confidence. And another small but very important topic is Hammett equation. Okay, there are questions being asked in GATE and CSIR both. So this makes a very important topic. Hammett equation, some of the times it's a little topic, kinetic isotopic effect. Yes, it's a small topic, and that's why I think it should not be skipped. You can just have a little idea about what is kinetic isotope effect, and if you want, you can see previous year questions also on this. Now, about the aromaticity. Aromaticity is also a small topic. What is covered in aromaticity? The Huckel's rule, the Craig's rule, the non-benzenoid aromatic compound, and the benzenoid aromatic compounds, right? So aromaticity is a different topic. That is, you know, who is aromatic, who is non-aromatic, and so on very well. But applications of aromaticity is a different topic. Okay, application of aromaticity, that is a different topic. Why? Because in the applications of aromaticity, you see the questions of the type that which is going to be the most acidic molecule, yeah, most basic molecule based on the concept of acidity. Yeah, which molecule has a higher dipole moment, right? Which molecule is going to have the least bond rotation, double bond rotation energy, right? Least energy barrier for double bond rotation. So all of these kind of questions, when you are seeing, you will understand that they are all the applications of aromaticity. If you have understood that, you can be very confident in answering those questions. Alright, so let's write in the next page, point number 22, applications of aromaticity. Then you have organic acids and bases, or I should write, I should write this as the pKa concept. You should be very thorough with this. pKa concept. What is pKa value basically? What is it used for? In organic or inorganic, wherever it is asked, what is the pKa concept, right? How can you compare the acidities and basicity of similar compounds, right? Yes. So the same concept is going to have acids and bases. Now talking about more important concepts, guys. Let's say stereochemistry I'm talking about. So the RS nomenclature. Yes, some examples of R and S nomenclature for one chiral carbon system, more than multiple chiral carbon system, all you should know. Then the D and the L nomenclature also you must know. Okay. Then enantiomeric excess. What is enantiomeric excess? What is optical purity? This topic is of utmost importance, although it is asked one or two questions only you're going to get, but it is asked, guys, and it is very, very important. We cannot skip this, right? So this is all about the stereochemistry. Then about the heterocycles, guys, don't study heterocyclic chemistry as a whole chapter. Heterocycles, only do the reactions first of all, and if you are getting interested into it, you can do the synthesis part also, but firstly I would recommend all of you to do the reactions. That is the reaction, the electrophilic aromatic substitution on pyrrole, on pyridine and quinoline and so on, right? Because those are similar and easy to predict, right? Reactions of heterocycles. Also, there are some questions which only ask you that what is the relationship between these two molecules. That is, are these two molecules enantiomer, diastereomer, or homomer? So, being able to identify the stereoisomer. Alright, identification of stereoisomer. Identification of stereoisomers. That is very, very important. Alright, because it is very basic, guys, and everyone is stuck at this, right? So you might be able to do this question, but you are in a hurry, or you might not have practiced enough. You are losing marks over here, right? Identification of stereoisomers. Then another important topic is topicity. If you're doing topicity, it's going to help you two ways, in stereochemistry, also in spectroscopy. It's going to help you a lot, topicity, right? Then topic number 30 is few reactions of asymmetric synthesis. Few reactions of asymmetric synthesis which I'm talking about is, let's say, Shapless epoxidation, I'm talking about Evans oxazolidinone, right? So you just have to do few examples which are going to help you in your examination, right? Point number 31, let's talk about some important classification and reactions of carbohydrates also. Of carbohydrates. And point number 32, amino acids. And if you are able to understand, if you are able to do both of these, you can proceed to nucleic acids also, right? Just to see what are the types of nucleic acids. That will be all. Now you don't have to go to terpenes and alkaloids. Why? Because it's very difficult to remember all of them, right? Carbohydrates and amino acids, mostly question you are going to get. See, it is very beneficial to do carbohydrates because most of the questions are on protection and deprotection, right? Using benzaldehyde and acetone and so on, right? And amino acid, usually the concept is asking you pK concept only. Why, what is the isoelectric point, or at this pH, how is this amino acid going to exist, right? Those small questions. And also mostly the questions are asked on the peptide sequencing. So yeah, if you see the previous year questions, you will know that what is asked from all of these topics. Okay. Yes, and these are small topics, guys, which are going to give you marks. So don't skip them, right? Then comes photochemistry. So photochemistry is huge actually, but we only have to study a little part of it. That is, we want to study the photochemistry of carbonyls, alkenes, right? Norris type 1, type 2 reaction, isomerization of alkene, या फिर McLafferty rearrangement of the alkene, or photochemistry of alpha beta unsaturated carbonyls, the diene and the dienone systems, right? All of these. So basic compound dipymethane rearrangement. I've already made a video on these reaction. You can check it out. All right, very simple. Only that much you have to consider for CA cyanide, right? Now moving onwards, yeah, I've made a list of all of these, right? So moving onwards, guys, what else do you have to study? Now I'm just listing down all the topics. As many as you can do, that will be awesome. Now come to the reagent part. First of all, we are going to talk about reduction. Study all the hydride reducing agents. The reducing agents which are having hydride donor. Hydride reducing agents. Those are going to be like lithium aluminum hydride, sodium borohydride, sodium cyanoborohydride, for example, more selective, dibal, and so on. All the hydride reducing agents. Then dissolving metal reduction. Dissolving metal reduction, it's important mechanism wise. Dissolving metal reduction. Alright, that is Birch reduction, for example, Bouwalt blank reduction, and Clemenson reduction, and so on and so forth. Okay? 37 is, please don't ignore BH3. Borane as a reducing agent. Very, very, very important, because there are so many types of boranes. You can use simple BH3, you can use diborane, you can use 9-BBN, alright, and you can use catechol borane. So many important points about the borane. So borane as a reducing agent, don't forget to do this. And if you have just made a list of all of these reactions, all of these important topics, and just ticking it off, it's going to give you immense confidence, right? Yes. Now let's talk about oxidation. Yes, these are all the important reducing methods. Let's talk about oxidation. Now, oxidation is very important. Oxidation by chromium based oxidizing agents, let's say PCC oxidation या फिर PDC oxidation. What is selective in these? PDC and PCC oxidation. Then there is KMNO4 oxidation. Then there is osmium tetraoxide oxidation. All the metal based oxidizing agents basically that you can do over here. Then all the non-metal based oxidizing agents, that is for example selenium dioxide, For example, tempo oxidation, for example, Des-Martin per iodine oxidation, DMP oxidation, right? So you can consider the metal oxidation by metal-based reagents, oxidation by non-metal-based reagents. That way you can do it. All right, it will be easier. You have divided into half already. All right, then we move onwards to, I have already written protection and deprotection, which comes into this. Let me just check once. Yes, there it is. Protection and deprotection comes into organic reagents only. Very, very important. So we have got the idea of what is the most important in the organic chemistry. All right, we have written 39 topics. Very, very important, all of these. Okay. Yes. Now we move onwards to inorganic, for example, and let's start with the most important topic, that is coordination. Okay, so what comes in coordination, guys? Don't consider coordination as a chapter because then it will be difficult. If you just divide it into topics, let's see, guys, not many topics are there. So isomerism you are going to start with. Isomerism in coordination compounds. Okay, isomerism in the coordination compounds. This is the most basic and most important topic. Then you also have to see the classification of ligands. Why? Because it will tell you the basic terms of hapticity, denticity, and so many things. Classification of ligands. All right, very important to know. Okay, then comes, after classification of ligands, you are going to study the Werner's theory and its classifications and its limitations. Sorry, Werner's theory and its limitations. All right, very, very important. Point number 43 is, now from Werner's theory and its limitation, you move onwards to the complexes. That complexes are formed based on the VBT. You try and explain them. That is the inner orbital and the outer orbital complex. Inner and the outer orbital complex. Okay. Yes, this is what you do. After understanding the Werner's theory, then you directly jump onto the limitations of VBT and crystal field theory. In the crystal field theory, first of all, you just have to see the introduction, the splitting of orbitals. So read a little bit of introduction and then understand how to calculation of CFSE. That is the next step that you do. Calculation of CFSE for different molecules, different systems also. Yes, point number 45 is, after understanding the CFT, you're going to look at its application. One of the application is understanding the spinel structure. Okay, just take it as a different topic. You have understood spinel, it's very good, very great. Now move onwards to Jahn-Teller distortion. Okay, move onwards to Jahn-Teller distortion. This is also a huge topic, plenty of things to consider. If you are done, then move onwards. Then consider hydration energy. Hydration energy and solubility. Okay, for all of these, please consider, very, very important. All right. Now, guys, we have done mostly the crystal field theory. We have already taken the important application part. Now we move onward to the limitations of CFT and we do the LFT, that is the ligand field theory. There you have to draw the ligand field orbitals, just like a molecular orbital theory, you have to do it. Okay, so you've understood the basics of coordination. Now you move onwards to the electronic in spectra. In the electronic in spectra, first thing that you must know is the Mulliken term symbols. Yes, you must be able to understand the term symbols. All right, very, very important. You must be able to find out the term symbols. Yeah, point number 50, you must also be able to find out the number of microstates. Yes, the number of microstates also you must be able to find out. Now, then you move onwards to spectra, the number of transitions and everything. So here I would write point number 51, organelle diagrams. plenty of important applications of orgel diagrams. Once you are able to understand orgel diagram, you will be able to answer maximum questions from coordination. After orgel diagram, you have to see a little bit of Tanabe-Sugano diagrams, only a little bit. Okay, TS diagram, you often call it the TS diagram, right? Tanabe-Sugano diagrams, very even though it's very, very important, only a little is asked. So just for some complexes like ruby, like some chromium based complex where it gives you phosphorescence. So that is, it's important to see the TS diagram of those configurations. All right. Then comes point number 53, that if you are considering magnetism, let's say you have jumped from the color in spectra to magnetism. Yes, if you are to understand the magnetism of different molecules, you will have to first see what are the different magnetic complexes, or let's say, what is the magnetism antiferromagnetic, what are antiferromagnetic compounds, yeah, for molecules, what are ferromagnetic molecules, what is ferrimagnetic molecules. You must also see what is the Curie's temperature, Niels temperature, all of these basic things you must see, and you must also be able to study the graph. Alright, graph on the molar magnetic susceptibility versus the temperature and so on. This is very, very important for the basics of magnetism. Then we move onwards to the magnetism of the molecules that we wanted to consider. Alright, magnetism of, let's say, different electronic configurations. Okay, magnetism or due to different electronic configurations into the complexes. That is very, very important once again. Now guys, 54 we have done, and as you have seen, we have only reached the half of coordination only, right? Organics and coordination. You see, this is such a big topic. Point number 55. Yes, what comes after magnetism? We now jump into the stability and the lability of complexes. So first thing, when we start doing the reaction mechanism, you do kinetic lability and inertness. There are a lot of students who are still confused. What is kinetic lability and inertness? So please clear out this thing, very, very important. Then next to it, we are going to see the thermodynamic stability. Okay, just see the thermodynamic stability. It is different from kinetic lability and inertness, right? 57 point is, yeah, I'm just going on writing. So let's write it in the next slide, point number 57. Now guys, when you are talking about the reaction mechanism, first thing that comes to your mind is substitution reaction. So here you are first going to study substitution in the square planar complexes where the trans effect is of huge importance. So study the trans effect separately, right? Substitution in square planar complexes. Now then, once you have studied this, then you move onwards to study the associative and dissociative mechanism. Alright, associative and dissociative mechanism for substitution in the octahedral complexes. Okay, so yeah, this is also very, very important. Now we have come to the reaction mechanism part. Only one thing is remaining, that is the electron transfer reaction. Point number 59. Just classify the reactions as inner orbital and outer orbital, uh, outer sphere mechanism, right? Inner sphere and outer sphere electron transfer. Okay, this is a basic topic, valence bond theory and hybridization, and it's going to help you in understanding that what could be the hybridization or the shape of different molecules. So VSCPR and this you are going to study together, absolutely, right? Then topic number 64. molecular orbital theory and the bond order. So it's asked for various species for nitrogen N2 plus, N2 minus, and so on. Bond order is asked separately. Now, talking about the bond order, guys, I'm reminded of the delta bond. It's a separate topic. The delta bond. You have a molecule like this, Re2Cl8 2 minus, and keeping this as a standard, many other molecules are asked just by changing the type of ligands, that what is going to be the bond order, or let's say which molecule is eclipsed, or let's say, yeah, plenty of questions asked on delta bond basically. So it's another important topic for all of you. Now let's consider point number 66. Yes, let's consider point number 66. So yes, guys. Now, see, we have discussed the chemical bonding, we have discussed coordination. We also have a small topic that is not so small, important topic, main group elements. Now, what are you going to study in main group elements, guys? You already have studied the periodic trends and everything, right? You already know about the hydrides and oxides and all those things. I'm not going to tell you to study the same thing again and again, but I'm going to just tell you some important topics over here, that from each group, which is the important topic that you can do. So let's say from group 13, you can do borazine. All right, you can do borazine and boron nitrides, right? Borazine and boron nitride polymer basically. This is what you can do from group 13, right? Group 14, let's say, what can you do from group 14? From group 14, you can do silicates and silicones. Silicones are super easy to learn, super easy. Just don't forget about it. Group 15, obviously you know about all the type of nitrogen acids and everything, nitrogen oxides. Here it is important to do the allotropes and oxoacids of phosphorus. Also put a lot of emphasis on the phosphonitrile chlorides. Phosphonitrile chloride, which are often known as phosphazine. Alright, often known as phosphazine with this formula PnCl2 whole N. Yes, guys, questions are asked in previous years on this, right? So from group 15, you can do so many things. From group 16, that is the oxygen family, what can you do? You can do oxo acids of sulfur. That is, what is the oxidation state of dithionic and dithionate, right? And so on. These have been asked in your examination. Dithionous acid and dithionic acid, right? So oxo acids of sulfur are very important. I'm just telling you few things, guys. I'm not telling you to study the whole chapter. At least this much you can do, right? Group 17, you can do interhalogen compounds. Interhalogen compounds like CLF, BRF3, right? So many molecules. Interhalogen compounds, and what are pseudohalogens? Those things you can do. Group 18, absolutely you only have one thing to study, xenon compounds, because there is only one thing that you can remember. And if there are some clathrates in the previous year questions, if there are clathrates which are asked, you can do a little bit of this also. So we have done plenty of topics over here: 66, 67, 68, 60, 69, 70, 71. Just try to finish them as topics, then only it is going to benefit you, otherwise not. Yes, topic number 72 is, when we are looking at inorganic chemistry, acid and base is another important topic. So all the Arrhenius theory, Lewis acid base theory, Bronsted-Lowry theory, these are basic things that you already know. Please consider the solvent system. All right. Very, very important. The solvent system is very important. Let's say I am saying that there is HF, then there is BRF3, then there is SOCl2, then there is ammonia. All right, acetic acid, N2O4, all of these, when they are considered as solvent systems, how the different molecules are going to behave in these solvents, please do those. All right, topic number 73. Yes, there's one important thing which you should have included in group 13 only. That is understanding the structure of boranes. Alright, boranes, the Wade's rule for finding out the structure of boranes, carboboranes, and the zintal ions. Alright, Wade's rule, and yes, the Stike's number also. Consider doing this, guys. Very, very important. Point number 74. Alright. So if you are doing coordination, you have already done the D block, and after that only the F block remains. So what are you going to do in the F block, guys? The applications of those metals, how are they useful, and the spectral and the magnetic properties. Electronic configuration, spectral and magnetic properties, only this much. And you just have one formula to understand, right? Just one formula which uses the G term, right, for the magnetic moment. Just do those things, right? Magnetic property. Yes, guys, the list is very long, but the list is, very defined, right? So I know that you are not going to study so many things, but you have to. All right, let's come to the spectroscopy part. Since we are done with coordination, obviously we'll do organometallics, but first let's come to spectroscopy part. So in the organic spectroscopy and in the inorganic, I'm mixing both of these. You are going to start with UV visible spectroscopy. You already have a playlist created. You can just check it out. UV visible spectroscopy, IR spectroscopy, along with that Raman spectroscopy also you can do simultaneously both of these. Then topic number 77, you have the proton NMR. In the NMR spectroscopy, there are huge things and all of these are similar, guys. So it will be really beneficial if you just study all of these spectroscopies together. 19 fluorine, 31 phosphorus, right? These are heteroatom spectroscopies. If you do them together, it's really good. Alright, and spectroscopy, ESR spectroscopy is very similar to NMR, and that is why it's important that you do both of these together. Then there is mass spectroscopy, yeah, mass spectrometry actually, and plenty of questions are asked on this, not separately, but mass is included in the structure determination of organic compounds. Okay, very, very important. Then you have one easy method is Mossberg spectroscopy. This is an easy method, easy spectroscopy method. You can do this. It's a separate topic. It won't take like more than 4 or 5 days. All right, point number 81. Yes, we have mostly considered all of the spectroscopic methods for organic and inorganic, right? Then we move onwards to bioinorganic. So guys, in the bioinorganic, what happens is you are asked the major oxygen transport and oxygen storage proteins, isn't it? Oxygen storage and transport proteins. Alright, this is what you are asked. Basic hemocyanin, hemoglobin, hemerythrin, all of these, myoglobin, all of these. Oxygen storage or transport protein. First of all. Second thing is, point number 82, you are asked what are metalloenzymes? Yes, it's a small topic. Metalloenzymes, you have zinc-based enzymes, you have iron-based enzyme, copper-based enzymes. So all of these are the basic ones that you study plenty of time. So ये आप एक बार देख लेना metalloenzymes के लिए, right? Then you have very, very important metals in medicine. Yes, guys, this is a ever growing topic. Metals in medicine, it's a ever growing topic, and this is not going to let you sleep in peace, because as many let's say you have studied plenty of metals, then also you'll think कि नहीं पढ़ा ढंग से, because ever growing thing this is, right? So point number 83, this was 84. The redox processes. Various redox processes in the biological system, that is the photosynthesis, nitrogen fixation, electron transport through the iron sulfur proteins, which you call as rubredoxin, the cytochromes, all of them fall under redox processes, right? So please study this also. Only 4 topics to complete bioinorganics, right? Point number 85, we are going to move onwards to now. Now, guys, as you can see, we have divided the whole syllabus into topics so that you get more clarity. Let's study. Let's see point number 85. Now comes the organometallic, guys. Start with the 18 electron rule. Very, very important. Organometallic, very, very scoring. 18 electron rule you're going to start with. Now, in the 18 electron rule, you will see that you are going to use the Wade-Mingo's rule. Wade's rule or Mingo's rule for calculating the skeleton electron pair, alright, of many complexes, higher nuclearity complexes. Point number 86, isolobal analogy. I've already made a video on this, so please check out isolobal analogy. Okay, yes, already made a video on this, guys. Please check this, very important. Point number 87. Now, what are you going to do? Metal alkene complexes. Okay, metal alkene complexes. Now, in the metal alkene complexes or metal alkyne complexes, how the different type of bonding is taking place, what is the effect of pi back bonding on that particular alkene, right? So please consider all of these factors. Then along with that, we also have metal phosphine. Direct questions are being asked on metal phosphine, guys, if you have seen the previous year papers. Okay, then point number 88, we have metal carbene. Okay, very minutely I am defining each and everything. I just hope that you're also writing down. Metal carbene. Okay, what are different carbenes? Fischer and Schrock carbene, definitely. Yeah, Grubbs catalyst is also a carbene, but we are going to use it in the alkene metathesis, right? So metal carbenes you have studied, you can also do alkene metathesis. Okay, this is more important as compared to this. Heterogeneous only few, homogeneous plenty of examples. Right, point number 93. Yes, we are very close to the end of the list, but not so early. It's going to end. So, yes, guys, I think we have completed all the organic and the inorganic section. Let's now start from the physical chemistry. Right. So, physical chemistry, if let's say you're starting from thermodynamics, you can start from just one topic, that is all the basic laws. The zeroth law, the first law, second law, and the third law. First, understanding the laws of thermodynamics. Okay, just understanding the law of thermodynamics. Then next is understanding what is the relationship, different relationship of the free energy with different molecules. Alright, free energy, and also consider along with it studying the partial molar quantity. Partial molar quantity and free energy. Alright guys, so moving onwards, point number 95. Okay, so many things are already done. I'm talking about chemical thermodynamics or the classical thermodynamics that we do, not the statistical one. Okay, this is very easy. After you have done the basic things, you can just directly jump onto thermochemistry. Alright, one another important topic, point number 96. Then you can also see ionic equilibria. All right, chemical equilibria and ionic equilibria, both it's going to consider basically. You can just check it out. Point number 97, phase rule. So if you find it difficult, it's okay if you skip the phase rule, but अगर आप कर लेते हो, then you know there are plenty of questions that you can get from here, phase rule के ऊपर, right? Then like this is thermodynamics in very short, right? So very briefly, I have explained thermodynamics, how you can complete. Point number 98 is doing in understanding all the crystal defects. All right, so understanding the crystal defects, what is a Frankel defect, what's a Schottky defect, and be able to do questions on this, that will be huge. Right, Bragg equation. Okay, 101, point number 101. So now we move onwards, guys. 101 point we have written down. Yes, now we move onwards and write 102. Very, very close we are to completing this whole thing. Now, guys, as you see, all of these are not very difficult, isn't it? Yes, zero, first law, second law, third law, not very difficult. Free energies, partial molar quantity, they are also doable, right? They are not going to consume a lot of your time. So you can just select some topics and get done with it and solve the previous year questions on them. Right. Then we come to chemical kinetics. Okay, first thing that we have to study is kinetics, different order of reaction and the rate law of the reaction. Yes. So different rate laws, that is for the first order, second order, third order, nth order, and so on. So different rate laws, that is what you have to study first of all. And turnover number. What is turnover number or turnover frequency? That also you have to know. Okay. 106 is photochemistry, guys. Photochemistry is nothing very difficult. There are 4 or 5 reactions only that you have to do. All right. And knowing the basic laws, nothing else. Then there is surface chemistry. Small topic once again, surface chemistry. Then you have electrolytic conductance. Alright, electrolytic conductance. That is the Kohlrausch's law, right? How is the conductance going to be affected in the presence of concentration dilute in, concentrated solution, all of those things, conductance measurement basically. So first you do electrolytic conductance in electrochemistry, then you do electrochemical cell. There are different types of electrochemical cells, galvanic cell, voltaic cell, and so on, and plenty of other things, salt bridge and on, so on, right? And then you have to do batteries also. What are different types of batteries which are being used? And guys, over here we have to do one more method, which is a small topic which you can do individually also. That is the titrations. Okay, the potentiometric titrations and the spectrophotometric titrations. Along with that, you also have polarography. Polarography is a small topic once again. You can get some questions if you just know the basics. All right. Now, what about point number 112? Yes, titrations and polarography we have written down. Then comes the important topic, that is quantum. I have written quantum later on. I should have written it first. Right, I have written kinetics and I have written solid state. Yes, and I have written thermodynamics, everything. All of these topics are written first, but quantum is of utmost importance. So what are we going to do, guys, in quantum? Basic quantum, that is the basic theories. First of all, we'll do basic quantum, right? According to the examination, the basic theories, basic assumptions of quantum mechanics, right? The particle in a box, degeneracy of orbitals, all of these are basic quantum. Okay, then we are going to move onwards to the operator algebra. operator algebra, and then the hydrogen atom. Alright, and then the hydrogen atom. Also, you can do plenty of topics in this. Then you also have different shapes of orbitals. Alright, and the tunneling effect. I just hope that you have written down the previous points. Right, I'm just erasing this slide. 115 points done, guys. Yes. Now, 116 topic is perturbation theory and its applications. 117 is group theory. Group theory, it's symmetry elements, the character table, right? Point groups, understanding the point groups, and also the selection rule. So four topics come under the same chapter, group theory. So I'm just writing the group theory as a whole chapter only. Okay. Then you have polymer chemistry or polymer kinetics. All right, polymer kinetics, that is what is the different molar masses, that also you can do. Molar masses only, also you can do the molar masses if you want to just get some more marks. Polymer kinetics is very simple. So you can do all of these topics, guys. And then lastly, I would suggest you to pay some good attention on molecular spectroscopy. Molecular spectroscopy and selection rules. Molecular spectroscopy and selection rules, and last but not the least, statistical thermodynamics. Okay. So for me, these two topics I just do at the end, and that is why I have just added these to the end of your list. 120 topic list is huge actually. If you've just classified the whole syllabus into different topics. Now, once again, I am going to ask you the same question, that first of all, guys, how are you liking this list? Is it important? Do you consider this is important? And if it is so, please write it down, and also please comment that which topic you want me to make a video on, and which strategy topic you want me to elaborate on, right? So many important topics we have already discussed, 120 important topics, right? So whichever you find best, you can tell me. Also, guys, before just quitting the video, please also comment that what you have liked in this session. Also, what do you want next from me, and any further point you want me to elaborate on. All right. So yeah, please do so. And if you already haven't subscribed to the channel, please do. Bye everyone. I'll see you all in another such video.